Hi everyone, welcome back. In this video, we are going to discuss top interview questions on Java functional programming, which covers Java 8 features as well. What is functional programming in Java? Functional programming in Java is a programming style where you write code using functions as the primary building blocks instead of focusing on classes and objects. The main idea is that functions should behave like mathematical functions, meaning the same input always gives the same output without modifying shared state. Java supports functional programming through Lambda expressions, functional interfaces, method references, streams, and immutability concepts. This allows developers to write cleaner, more concise code that avoids unnecessary side effects. Functional programming became fully mainstream in Java after Java 8, which introduced the Java.util.function package. This brought interfaces such as function, predicate, supplier, and consumer that make it easy to pass behavior as arguments. Functional programming improves readability, encourages declarative style, and is extremely useful in parallel processing because functions that do not modify shared state are safe to run in multiple threads. Overall, functional programming helps write cleaner, safer, and more testable Java programs. Next question: what is a Lambda expression in Java? A Lambda expression is a short block of code that you can pass around as if it were an object. It allows you to write functions inline without creating separate classes or methods. Before Lambdas, developers had to write long anonymous inner classes even for simple tasks like sorting or filtering. A Lambda expression contains parameters on the left side and the implementation on the right side, separated by an arrow symbol. It is used wherever a functional interface is expected. A functional interface is simply an interface that contains exactly one abstract method. Lambdas make Java more expressive, reduce boilerplate code, and support functional programming techniques like passing behavior as data. They are heavily used in stream operations, event handling, filtering logic, logging strategies, and callback implementations. By eliminating unnecessary verbosity, Lambda expressions help developers focus on business logic rather than infrastructure code. Next, what is a functional interface? A functional interface is an interface that contains exactly one abstract method. It may contain multiple default or static methods, but only one abstract method is allowed. This single abstract method acts as the contract for Lambda expressions. Java provides many built-in functional interfaces in the Java.util.function package. For example, function represents a transformation operation, predicate represents a condition, consumer represents an action, and supplier represents a value provider. Functional interfaces are extremely important because they allow Java to treat functions as first-class citizens. Without functional interfaces, Java would not support Lambda expressions or method references. Functional interfaces also help simplify code, improve reusability, and promote a more declarative programming style. They play a major role in stream pipelines, concurrency utilities, event-driven systems, and modern Java frameworks. Next question: what is the Stream API in Java? The Stream API is a powerful abstraction that allows you to process collections in a functional and declarative way. Instead of writing loops manually, you build a pipeline of operations that transform data step by step. Streams allow operations such as filtering, mapping, sorting, reducing, grouping, and collecting results efficiently. They support both sequential and parallel execution, which helps utilize multi-core processors automatically. A key characteristic of streams is that they do not store data. They operate on data from collections, arrays, or I/O sources. Streams are also lazy, meaning they do not run until a terminal operation is invoked, such as collect or for each. The Stream API makes code shorter, more readable, and less error prone. It helps avoid side effects by encouraging pure functions inside pipelines. Overall, Stream API is one of the most important features that brought functional programming into Java. Next, what is the difference between map and flatmap in Java streams? The map operation transforms each element of a stream into another value. For example, you can convert strings to uppercase or extract fields from objects. Each input element produces exactly one output element. Flatmap is different. It transforms each element into a stream and then flattens all resulting streams into a single continuous stream. This is useful when each input element may produce multiple output values. A simple conceptual example is when each user has a list of phone numbers. Using map gives you a stream of lists, but using flatmap merges all phone numbers into one unified stream, making them easier to process. Flatmap is heavily used in parsing, nested data processing, file reading, combining multiple sources, and dealing with optional or multi-valued responses. Map handles one-to-one transformations. Flatmap handles one-to-many transformations. Next question. What is a method reference in Java? A method reference is a shorthand syntax used to refer to an existing method without executing it. It is a more readable alternative to Lambda expressions when the Lambda body simply calls another method. There are 4 types of method references: reference to a static method, reference to an instance method, reference to a constructor, and reference to an instance method of an arbitrary object. For example, if you need to print each value in a stream, instead of writing a lambda like xarrow system.out.println x, you can use system.out.println directly. Method references improve clarity and reduce redundant syntax. They are especially useful when used with streams, optional values, and callback APIs. Method references form an important part of modern Java and help developers write expressive functional style code. Next, what is immutability in functional programming? Immutability means that once an object is created, its state cannot be modified. Functional programming encourages immutability because it eliminates side effects and makes code safer. In Java, immutable objects include string, wrapper classes, records, and objects you design with final fields. Immutability ensures thread safety because no thread can change the state while another thread is reading it. Immutability also improves referential transparency, which means the same function call will always produce the same result. Although immutable objects may require new object creation and updates, modern JVM optimization makes this extremely efficient. Immutability is crucial in stream operations, parallel computations, and functional style API design. Next question. What is a predicate in Java functional programming? A predicate is a functional interface that represents a condition or test that returns true or false. It takes one argument and produces a Boolean result. Predicates are widely used for filtering collections, validating input, checking conditions, and driving conditional logic inside streams and optionals. Predicates also support chaining using methods such as and, or, and negate, which allows developers to combine multiple conditions in a functional way. Predicate encourages clean declarative logic and avoids deeply nested if-else blocks. Next, what is optional in Java and why is it used in functional programming? Optional is a container object introduced to represent the presence or absence of a value without using null. In functional programming, optional helps developers avoid null pointer exceptions and encourages explicit handling of empty results. Instead of checking whether a value is null, optional offers high-level operations such as map, flatmap, filter, or else get, and if present. Optional fits naturally into functional programming because it supports chaining, transformations, and safe operations without branching through if-else conditions. The goal is to make code more expressive and avoid hidden errors caused by null references. Optional is also used in methods where a value may or may not exist, such as searching elements, parsing input, or reading configurations. This makes the developer handle missing values intentionally rather than accidentally ignoring them. Overall, optional promotes safer, more readable, and more predictable functional style code. Next question. How do you handle exceptions inside Lambda expressions? Lambda expressions do not allow checked exceptions directly because functional interfaces do not declare them. To handle exceptions, developers typically wrap the Lambda logic in a try-catch block inside the Lambda body. This is useful for simple cases where exception handling is local. For more complex cases, developers write custom wrapper functions that convert checked exceptions into unchecked ones. This allows the Lambda to remain clean while still propagating meaningful errors. Another approach is to define functional interfaces that declare checked exceptions, although this requires custom interfaces instead of built-in ones. Exception handling in Lambdas is essential because Lambdas are often used in streams where exceptions cannot be thrown from intermediate operations without breaking the pipeline. Wrappers and utility methods help keep the code functional while still managing errors gracefully. Proper exception handling ensures cleaner pipelines and avoids breaking functional flow. Next, what is lazy evaluation in streams and why is it important? Lazy evaluation means that intermediate operations in a stream, such as map or filter, do not execute immediately. They only run when a terminal operation like collect, reduce, or for each is invoked. This makes streams efficient because computations occur only when needed. Lazy evaluation allows Java to optimize the pipeline by combining steps, avoiding unnecessary work, and short-circuiting when possible. For example, if a filter finds a matching value early, operations after that may be skipped. Lazy evaluation is crucial for performance, especially when dealing with large datasets, infinite streams, or complex transformations. It also ensures that functional pipelines remain lightweight, with intermediate operations simply describing what to do rather than executing immediately. This model is a core part of functional programming in Java because it enables expressive and efficient data processing. Next question. What is a supplier in Java functional programming? A supplier is a functional interface that takes no input but returns a value when called. It is commonly used for lazy initialization, deferred execution, and object creation. Instead of passing a ready value, you pass a function that produces the value when needed. Suppliers are especially helpful in scenarios where computing a value is expensive and should only be done if required. They are also used in caching frameworks, dependency injection, and APIs that need flexible callback creation. In functional programming, suppliers encourage designers to think in terms of functions rather than objects. By delegating responsibility to a supplier, you create more modular and testable code. Next question. What is a consumer and how is it used in Java functional programming? A consumer is a functional interface that accepts one input but does not return a value. It is used when an operation performs an action such as printing, logging, updating a counter, or processing items in a stream. Consumers are commonly used in for each operations, callback handlers, event processors, and APIs that require action-driven logic. They help isolate the action logic and make pipelines more expressive. In functional programming, consumers encourage writing side effect actions in a controlled manner. Consumers can be chained using and then, enabling developers to build sequential action pipelines. This supports more modular and composable designs. Next, what is a BiFunction and when would you use it? A BiFunction is a functional interface that accepts two inputs and returns one output. It is used in scenarios where combining, transforming, or aggregating two values is required. For example, concatenating strings, merging objects, calculating totals, or applying arithmetic operations. BiFunction is useful in functional programming because it allows combining two independent data sources or applying complex transformations within a stream pipeline. Developers often use BiFunction in mapper transformations, reduce operations, and builder-style APIs. It also supports functional composition when paired with function, allowing developers to build more expressive and flexible pipelines. With BiFunction, code becomes cleaner because combining logic is separated from looping or control flow. BiFunction plays an important role in functional interfaces and supports writing reusable and declarative logic. Next question: what is short circuiting in Java streams? Short circuiting refers to the ability of certain operations in streams to stop evaluating once a condition is satisfied. This is particularly useful in operations like find first, any match, all match, and none match. Short circuiting improves performance because the pipeline does not need to process remaining elements once the result is known. For example, if any match finds a match in the first few items, it stops evaluating the rest. This behavior is aligned with functional programming principles because operations describe what needs to be done rather than how to iterate over the elements. The JVM optimizes the iteration automatically. Short circuiting also supports infinite streams. Without short circuiting, operations such as find first could never complete. Overall, short circuiting makes functional pipelines efficient, predictable, and expressive. Next, what is parallel stream processing and when should it be used? Parallel streams divide a stream's data into multiple chunks and process them across multiple CPU cores. This can significantly improve performance for large datasets or CPU-intensive operations because computation is distributed. However, parallel streams should not be used blindly. They work best when operations are stateless, independent, and thread-safe. Parallel streams can degrade performance if the task involves I/O operations, synchronization, shared mutable data, or small datasets where parallel overhead outweighs benefits. Parallel streams fit scenarios such as heavy mathematical operations, batch analytics, and processing large lists. They leverage fork join pools under the hood to manage parallel execution. Parallelism is an advanced feature and must be applied carefully to avoid unpredictable performance. Next question: what is a reduction operation in Java streams? A reduction operation combines elements of a stream into a single result. This could be a sum, a maximum value, a string concatenation, or a custom aggregated result. The most common reduction methods are reduce and collect. Reduction is important because it enables complex transformations without explicit loops. Instead of iterating manually, you describe how values should combine, and the Stream API handles iteration, aggregation, and parallelization. Reduce is typically used for mathematical operations or combining values into a final result. Collect is used when you want to produce a collection, a map, or a custom object. Reduction supports declarative programming by letting developers focus on what result they want instead of controlling iteration mechanics. It is a cornerstone of functional programming in Java. Next, what is a higher order function in Java? A higher order function is a function that either takes another function as an argument, returns a function, or both. Java supports higher order functions through Lambda expressions, functional interfaces, and method references. Higher order functions allow behavior to be passed around dynamically. This is extremely useful in callback systems, event-driven programming, custom validation logic, and transformation pipelines. In Java streams, operations such as map and filter accept functional arguments and are therefore higher order functions. They enable developers to write declarative code that focuses on what should be done rather than how iteration should occur. Higher order functions enable modularity, reduce repetition, and make systems more flexible. They are foundational to functional programming in Java. So these are the top interview questions on Java functional programming.